Artificial intelligence is often described as a software revolution, but the real competition shaping the future of AI is not happening inside code. It is happening in infrastructure, data, centers, semiconductor factories, energy systems, and the global networks capable of powering machines that think. The world has already entered a race. The AI infrastructure race. Artificial intelligence feels invisible. We interact with it through applications. A chatbot answering questions, an algorithm recommending videos, a system generating images or writing text. From the outside, it feels like intelligence appearing inside software, but beneath that interface lies something enormous, a global technological infrastructure that most people will never see. Artificial intelligence does not exist only in algorithms. It exists in machines. Massive facilities filled with processors, gigantic data centers consuming extraordinary amounts of electricity, factories producing microscopic chips with billions of transistors, global supply chains transporting components across continents. Artificial intelligence is not just software, it is infrastructure, and the world is now racing to build it. To understand why this race matters, we need to understand how modern artificial intelligence systems actually work. Training an advanced AI model requires enormous computational power. These models learn by processing massive data sets. Image, text, video, audio. Every piece of information is analyzed repeatedly while the system adjusts millions and sometimes billions of internal parameters. Each adjustment requires mathematical calculations, and those calculations happen trillions of times during training. The scale of computation required for modern AI systems is staggering. Training a large neural network can require weeks of continuous computation, clusters of thousands of processors working simultaneously. The machines performing these calculations are specialized processes called GPUs, graphics processing units. Originally designed to render graphics in video games, GPUs turned out to be perfectly suited for artificial intelligence. Unlike traditional CPUs, which process tasks sequentially, GPUs perform thousands of calculations at the same time. This parallel architecture allows them to accelerate the massive matrix operations used in neural networks. Over the last decade, GPUs have become the engines powering artificial intelligence. Entire computing clusters are now built around them. Inside modern AI data centers, thousands of GPUs are connected through high-speed networks. These machines work together as enormous computational engines. The result is unprecedented computing power. But building these systems requires more than just processors. They require infrastructure. Massive buildings designed specifically for high-performance computing. Facilities capable of powering thousands of machines simultaneously. Cooling systems designed to remove enormous quantities of heat. Because AI computing produces heat, a lot of heat. Large GPU clusters generate so much thermal energy that entire cooling systems must be engineered around them. Some facilities circulate cold air through massive ventilation systems. Others use liquid cooling technology that transfers heat directly away from processors. These systems are essential because even slight overheating can damage sensitive hardware. But cooling is only one part of the infrastructure challenge. Power is another. Artificial intelligence consumes electricity at an extraordinary scale. A single large AI data center can consume as much electricity as a small city. Energy grids must be capable of delivering stable power to thousands of machines operating continuously. In some cases, entire energy infrastructures are expanded specifically to support new computing facilities. technology companies are investing billions into building these systems. New data centers are being constructed across the world. Some are located near renewable energy sources. Others are built in colder climates where natural cooling reduces operational costs. Many are placed near major fiber optic networks to ensure high-speed connectivity, because data must move quickly between machines. Artificial intelligence requires enormous data throughput. Thousands of GPUs exchanging information continuously. High-speed networking technology has become a critical component of AI infrastructure. Specialized switches and fiber optic cables allow clusters to communicate at extraordinary speeds. Without these networks, large AI systems would be impossible. Even these facilities rely on something even more fundamental: semiconductors. The processors powering AI clusters must be manufactured. And manufacturing advanced semiconductor chips is one of the most complex industrial processes ever created. Modern semiconductor fabrication plants operate at microscopic scales. Transistors measured in nanometers. A nanometer is 1/1000th of a meter. To put that into perspective, a human hair is roughly 80,000 nanometers wide. Inside semiconductor fabs, engineers build structures thousands of times smaller. The manufacturing process involves hundreds of highly specialized steps. Silicon wafers move through massive machines that deposit, etch, and pattern microscopic layers. Each wafer may contain hundreds of chips. Each chip may contain billions of transistors. The precision required is extraordinary. Even the smallest contamination can destroy an entire batch. For this reason, semiconductor factories are among the cleanest environments ever constructed. Air inside these facilities is filtered thousands of times per hour. Workers wear specialized suits to prevent microscopic particles from entering the production environment. Building these factories is extremely expensive. Modern semiconductor fabrication plants can cost tens of billions of dollars. Only a handful of companies in the world can operate them. And these facilities have become some of the most strategically important locations on Earth, because the future of artificial intelligence depends on them. Technology companies now compete not only to build better algorithms, but to build better infrastructure. Data centers, chip factories, energy systems, global logistics networks. Artificial intelligence is transforming the scale of technological infrastructure. The next generation of AI models will require even more computing power. Researchers estimate that future systems may require orders of magnitude more computation than today's models. This means more GPUs, more data centers, more energy. The infrastructure supporting AI will continue expanding. Entire regions are becoming technological hubs for artificial intelligence infrastructure. Governments are investing heavily in semiconductor manufacturing. Countries recognize that control over AI infrastructure may influence future economic power. Artificial intelligence is not only a technological revolution, it is an industrial transformation, a transformation of computing, energy, manufacturing, and global logistics. The race to build AI infrastructure is already underway. Technology companies are constructing massive computing clusters. Semiconductor manufacturers are building new fabrication plants. Energy systems are expanding to support unprecedented electricity demand. This race will shape the future of artificial intelligence, but it will also shape the future of the global economy. Because the machines that power intelligence require something fundamental: power, infrastructure, and the ability to build systems at extraordinary scale. Artificial intelligence may feel digital, but its foundation is physical. And the countries, companies, and engineers who build that foundation will shape the next era of technological civilization. The AI infrastructure race has already begun, and the systems we build today will determine how powerful the intelligence of tomorrow can become.